Hi again. Now we will continue with how can we create our algorithm structure. Initially, we will create how can we create our solutions step by step. For example, in this part, we will withdraw an amount of money by using the ATM. So it is a daily thing, as you know. So let's examine the ATM withdrawal algorithm that allows us to obtain cash from our bank account step by step. And we have no order number for these points, as you know, but we have an order. Initially, the first one, go to an ATM belonging to the bank where the account is located, enter the waiting queue in front of the ATM. Wait in the queue until the transaction is in order, and then when the transaction is in order, the ATM card is inserted into the ATM card slot, and then enter the password for the ATM card and press the enter button, and then the withdrawal menu is accessed. Then the amount of cash to be withdrawn is determined and the continue button is pressed. After this step, the ATM removes the ATM card from the card slot. I will check this part. Yes. Okay. And I'm recording. Yes. And then ATM card is taken back from the ATM. The ATM fills the cash into the cash slot. The cash is taken from the ATM. The withdrawal process is completed and the transaction queue is excited as you see. So, it is just an example, the steps of the withdrawing the money by using an ATM, as you see. Just like this example, you can create your own daily algorithm steps. So, as we stated before, you should define your input and output information. So, we have some basic features, as you see. And clarity. The steps that make up the algorithm must be defined correctly and precisely. And accuracy. Algorithms that can work with different input information must produce a correct output for each input. And finiteness. You should define and criteria for each structure. You should connect your processes to the end point. It's so important for us. Otherwise, you can encounter with some infinite loop problems into your algorithm. Efficiency. The steps that make up the algorithm must be completed within an acceptable time for the work being done. And generality, an algorithm must be applicable to all problems of the same type. So actually, we are talking about this. If you are trying to solve some adding operation, which which is calculating the sum of two numbers, you should define two variables. You cannot write directly two plus three equal to five. So you should apply this generality problem. You should define x as a first number, y as a first number, and as some variables. They are not exact numbers. You should define some variables, not direct number values. And algorithm representation methods. There are different methods used in defining and displaying algorithms. The main ones are spoken language or daily language, human language, and the second one, flowchart, and the third one, pseudocode. Flowchart and pseudocode are so important for us because you will create your own flowchart and pseudocodes in your exams, in your exam questions. You will create your own solutions. Human language way. And in this algorithm, as you see, and in this problem, we are trying to find the greatest common divisor value of two positive integer numbers. And so here, the explanation. We have two positive integers as an input, right? And then we have an output value. What is it? It is greatest common divisor value. And step one, name the larger number A and define the smaller number as B, and divide A by V and name the remainder as K. If K is not, if K is different from 0, assign the value of B to A and assign the value of K to B and return to step 2. Step 2 here. If our K's value is 0, the greatest common divisor value is B. So let's see the example for this solution. For example, we are giving some specific numbers, so 8 and 12 in here. So the larger one, bigger one will be A, and the smaller one will be B. And then here's the modulation operation. So here's the remainder part. So we will remain value as K 4. So the K is not equal to 0. And then we will update our A's and B's values as B and 4 is the K value. As you see, we update these values and then we will go back to the step 2 again because our K is not equal to 0. Okay, and then after this step, we are using the stage and our remain value is 0. So here is the remain value is 0 and you can show this greatest common divisor value at the output as B's value. It is 4. So here is the flow chart. So we have a top start points for our flow chart. Now we are using some specific shapes in here. The problem is the same, but showing type is different. Now we will use this previous stage while we are creating our flow chart. We have some specific symbols. I will show these symbols and shapes in the second slide, which is related with the short week content. And then we are showing this result to the output as a result. And pseudocode, it is actually, it's so similar with a code in here. As you see, we are defining a procedure which is named as uplet, and we have two inputs, and here is the type for these input values. These are positive integer numbers. And in the second step, we have a modulation operation. We are assigning always right to the left in here, and we are calculating this calculations result, and we are assigning this result to the case, and it's the direction. And is there any operation for this? No. Let's continue. And then we have a loop. We will repeat this code block again and again while this terminating criteria will be true. So our k, our remain value, if is not equal to 0, we will run these inner steps again and again. So we will update this a value by using this b's value. And we are updating b's value by using k's value. And then we are updating k again by using this one. If our k is not equal to 0, so we will repeat this inner step, step 4, and line 4, 5, and 6 again and again. If this one equals to 0, we will terminate this while loop in here. We will jump to the line 7. Then we will print this latest value, and we are ending this procedure. And this was another example. Actually, you can solve this kind of math problems by using some different approach, and you can encounter with some different solutions with some different pseudocodes. As I said before, this algorithm creation is just like your fingerprints. You can create some different solutions, and also it um, not saying that actually one of them is false solution. No, all of them can be the true, but you can create some different true solutions, different correct solutions. And actually, we talked about these classifications of algorithms. Actually, you can encounter so many different subtypes for this algorithm. It's so huge world, as I said before. And here, actually, recursive algorithm is so you can encounter possibly. And backtracking algorithms, divide and conquer algorithms, possibly you will encounter again, for example, in sorting operations, sorting algorithms, or sorting algorithms, we may encounter with this divide and conquer algorithm, and also dynamic programming and greedy algorithms and brute force algorithms. In this term, we will see, for example, this divide and conquer algorithms in sorting algorithms. Data structures, we have so many different types for these different data structures. Actually, how it's so dependent with your problem type again. Um, we want to save our data, but what are you carrying? Are you carrying time? Are you carrying memory size? So access time, the processing time. So this criteria is so important for your defining data structure part. And also, you can define your data, you can define your variables one by one individually, but we are generally using these structures. For example, arrays. Actually, we have some shelves, bookshelves, and we are putting our structures in this cells. We have no order. We have just a size for this bookshelf and linked list. If you have some pointers um, which are showing the next cell address number, and actually it is the advanced version of these array structures. So these structures called as linked list and queues. These queues actually this data structure is another um, core topic. It is a wide structure, and for example, if you want to see this array structure, um, possibly it will get at least 1 week for us because we have some multi-size arrays, two-dimensional arrays. For example, for this linked list, it can get at least 2 weeks or 3 weeks because we have some subtypes for this linked list. Double linked list, other link types, and also queues and stacks. Queues are similar with our real life queues. For example, ticket queue actually. And here is the queues first area, queues last area. If you enter firstly, you will actually will be the first one if you remove something from this queue and first entered one first actually will first be removed from this queue. But the texts are similar with the queue structures, but it is similar with this box logic. If you are try to imagine you are putting some multiple books into this box and you are putting your first box and then second box and then third box. If you want to remove any book from this box, you will get the latest one. So the third box will be the first removed book from this box. Actually, this logic called as first in last out logic. So um, in the three heaps and hash tables, they are similar structures. These heaps can be called as the packed trees maybe. And we have some hash tables. Hash tables, they are using some hash address numbers while they are storing these variables or values or data into our memories. And trees, for example, um, it is just like your family tree. So we have a connection. We have some child nodes, we have some root nodes, upper nodes, sub areas, upper areas. By this way, we can store our data. So, for example, graphs, we will see the graphs in our last week. Um, and also you can encounter with some different data structures. And after the class, try to create this examples results on your own. For example, the act of washing clothes with a washing machine can also be described with the help of an algorithm. The um, washing algorithm describes the washing and cleaning of dirty clothes. How do we create the possible steps of this algorithm? Try to solve your own algorithm and then compare with my algorithm. So here is my algorithm. My advice, initially, try to create your own solution and then compare your solution with my solution. Compare your algorithm steps with my algorithm steps. Possibly, both of them will be the correct solutions, but the orders can be different. So here, I will repeat my previous sentence again. Creating an algorithm actually is so similar with your fingerprint. And let's continue with some algorithm creation problems. Where was it? In here. So as I said before, we will have no class in our next week, and in our fourth week, we will continue with our number system. So we will be done with our first 3 weeks, and then we will continue with our fourth week chapter. In our fourth week, we will lose nothing. And let's continue with the flowchart creation and pseudocode concept. So, what is flowcharting? A set of steps that generates a finished sequence of elementary computational operations leading to the solution of a given up problem is called an algorithm. It can be any definition. You don't need to memorize anything again. Just try to understand the logic. A pictorial representation may be used as a substitute for an algorithm. Such a pictorial representation is called a flowchart. Formally speaking, a flowchart is a diagrammatic representation of the steps of an algorithm. In a flowchart, boxes of different shapes are used to denote different types of operations, and these boxes are then connected by lines with arrows denoting the flow or direction to which one should proceed to know the next step. Actually, we can encounter with this flowcharting operation in two categories, program flowchart or system flowchart. In your system analyze class, you will possibly encounter with the flowcharting operation. So we are modeling some subsystems, and also they should be an interaction with each other. And by adding some arrows, we are creating this interactions direction. But in this class, our job is creating program flowcharts. So for program flowcharts act like mirrors of computer programs in terms of flowcharting symbols. They contain the steps of solving problem unique for a specific result. And system flowchart contains the solution of many problems units together that are closely related to each other and interact with each other to achieve a goal. For example, as a university, we have so many different departments, but if we want to run the system, we should work each other. We should create an interaction between these departments. Yes, we have some different jobs. We have some different tasks in the system, in this university system, but we are sharing some common documents, for example. And also in the system declarations, we can create this kind of system flow chart to demonstrate whole plan of this system. We will first focus on program flow chart as you see. And first, only the standard symbols should be used in program flow chart. So you cannot use some other symbols into your flowchart. you should use these standard symbols. The program logic should be depict the flow from top to bottom and from left to right. So we will create our flow chart from top to bottom and from left to right. And you can use both approach, but my choice top to bottom, not left to right. Each symbol used in a program flowchart should contain only one entry point and one exit point, with the exception of the division symbol. This is known as a single row. Actually, if you are if you are trying to solve some multiple problems into the same algorithm, you will possibly struggle to create this flowchart. Initially, try to explain first solution, first problem, and then you can add the other approach. You can add the third approach in the same algorithm if you want to solve these multiple problems. The operations shown within a symbol of a program flowchart should be expressed independently of any particular programming language. All decision brains should be well labeled. Please don't explain everything into this cell and write briefly and write actually clearly into this shapes. So our standard symbols, so terminal character start symbol and stop symbol, you can use the first one. And also we have an input output symbol in here. And we have a rectangle, as you see, to show this computer processing part. And if you have some predefined processors, processing operations, you can call these functions by using the shape. If you want to add your command to the right side of your shapes, you can use this rectangular thing. And we have a flow line arrow. It shows the direction of this flow. And if you want to show this documentational input output parts, for example, instead of using this input output shape, you may use this parallelogram into your diagram. The regional part, we have a diamond shape as you see. If you have some conditions, for example, if you want to check your user age, what if greater than 18 or not, you should write this condition into this diamond shape and you can add this. I want to remove this other part, sorry, into this part. So for example, we have a flow from the left side and we have a yes area and we have a no choice according to this one. And 8, we will compare our 8 with the 18 value. If this one is greater than 80, so we will navigate to this direction. If the answer is no, we will go to this way. So please don't add one more direction. So your answer can be true or false, yes or no, 0 or 1. So you cannot add one more or two more or some more output from this decision shape. So you can add some multiple inputs to this decision area, but your answer can be just two of them. And if you have some longer flow charts, so actually in our simple examples and also in our um, even if our even if into our exam questions, you don't need to use this on-page connector shape. If you need to use some multiple page for your flow chart diagram as a connector, you can use this shape into your flowchart diagram. And it is the opaque connector symbol. And let's cook right together. In here, in this example, as you see, we have a pseudocode. Actually, it is similar to human language, as you know. And we are explaining this problem, the problem solution step by step. Step one, take the rice to be cooked and then procure the container. And for example, take the container, take the water, and wash the rice in the water. Put the rice into the container, pour water into the container. If water level is equal to 1 inch above the rice, so then we will jump to the step 8, as you see. Else, we will go back. We will continue pouring step. And in here, if we're done with the pouring operation, so we will check what if this rice is boiled or not. If it is boiled, we will jump to the step 12, as you see. So if the answer is no in the else operation, so we will continue for the filling operation, and then we will go back to this ninth step, as you see. And if we are done with this boiling operation, we will turn off the flame, and then we will move the container of the stove. We will distribute cooked rice, and then we will terminate our solution. And here is the flowchart of this previous step. And here we have some command parts. As you see, we are adding our command by this way. It's not an obligational part. Actually, you don't need to put every command for your areas. If you need, you may add, but it is not a mandatory situation. And in here, as you see, if you want to declare your inputs, actually, you should use this parallelogram. Okay. If you have some processing operations which are related in the background, which are related into your computer's processing area, so at that time you need to use this rectangle, as you see. So let's see step by step. Input area. We are taking the rice, we are taking the container, we are taking this water. So all of them can be defined as input. Then now we are running something. We have some functions. We have some action, as you see, and wash the rice in the water, and then put the rice in the container. Then we will start for this pouring operation in here. Pour on water into the container. It's a clear function actually. We don't need to declare any input or output. So now we are taking, what if this water level is greater this volume? If the answer is yes, so light the burner of the stove. If the answer is no, so we will continue for this pouring operation again. And so it's continuing by this way. And let's continue with some different examples. Actually, this assignment direction is so important because it can be complicated by you. It it can be seem complicated actually. And here, if you see this kind of thing, it means we are updating our A value by using B's value. So let's try to think, try to imagine we have some memory cells. Why? Huh. So first one, A's value, and these are variables. And A's initial value is 10, and B's initial value is 50. So by using this, you can see instead of this, actually, you may encounter this one. So it means assign B's value to the A variable. It means that actually. So what are we doing in that code line? So actually, we are assigning B's value to this area, and then now A is 15. So It doesn't mean that the value of B is lost. Actually, we still keep this B's value in this memory area. And let's try to understand this first question solution. Require two numbers. Why? Because we want to find the sum of two given numbers. So the initial values, input values must be two input numbers, two positive integer numbers. So here's the input. And output will be sum. Initially, I'm writing my input and output number one and then number two. So it will be input, it will be output. Here, initially, you should create this left side. After you create this left side, you can easily create your flowchart. So retest A's and B's value input as step one, and then calculate the summation and then assign this value to the S variable. Then print S value at the output and stop. So it means input A and B. So A represents the first number, B represents the second number, S represents the sum of these given values. As you see, these are comment areas. And so we are using this parallelogram shape because it's an input area. And also we are using this shape again for this output area. So we are using this rectangle area because it's just a processing area. So it's not related with this inputting and outputting part. So it's just a background operation. We have no interaction with the user at this rectangular area. Now we will try to calculate the average value of these two numbers. Initially, we should create this left side again. We will use two inputs and then we will calculate sum value. And then by using the sum value, by dividing two, we will calculate average. And then we will print this average value to the output. In this part, as you see, instead of this, you may write as equals A plus B. It's the same thing actually. Actually, the other questions will be an exercise to you, will be an example to you after the class, and especially in our next week. Please try to solve these questions on your own. And I will, stop, not this one. What about this? For example, um, for your last question, is this last question? No, no. First before last question. One before, sorry. In here, we have three numbers. Yes, we are trying to calculate the average grade value of these midterms, which is related to a specific student. And we have three input values. We will calculate, and also we have one more input value, which is a student number. And then we will calculate the average value. Then we will print registration now. It means student ID and then average grade value. So I want to, where was this? This one, this one, this one. And actually, as I said in our previous week, create our flowcharts. I'm planning to use this Draw.io, and you may pick the flowchart type in here. You may give any name, for example, example one, maybe save. So, initially, my advice, remove everything, and we have some general shapes at the left side. And also, I want to get this one as print screen. All of them actually, so simple problem to solve. But, and make a resize. So, we will create this pseudocode flowchart into here. Now, we know we need to put a start point and a stop point. By copying and pasting, you can easily add these multiple shapes and stop point. Yep. Actually, after this, stop point. And first one, in this first step, it must be input, and we will read registration number. This reg now name is so important because we will use the same naming, same names for these variables. By this way, actually we can create this connected pseudocode and flowchart structures. In this part, we will read, and also initially before this, if you want to inform your user, you may print some information message to your user. Enter, for example, please, yep, 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 enter student ID. I want to decrease this. Yeah, it seems okay. Then read. So I'm writing the same reg. No. So it must be the same name. So here and here. So we read this and then we will read midterm grade or exam grade. Please enter exam grade. Now we will read, or it can be an input. So we are reading this one and you may write input. It can be much better than the read. And now we will read, so M1, M2, and M3. So in this part, we're done with this reading operation. We're done with this input operation. Now we will add our processing part by adding this structure. So we have P, as you see, P equals M1 plus M2 plus and M3, as you see. And then we will calculate average by using the C's latest value. And now it must be AV, AG in uppercase, and then no, divide by 3, right? Yes, by 3. Now we are done with this processing operation. We will print. So according to the step 5. We will print registration number. It must be the same name. I'm warning you again. Registration number and then average. So that's all. If you want to align them, sorry. Here, arrange cards. So aligning by this way, you can easily align them. And also by using control scroll, you can add zoom in operation. So in here, as you see, you can easily connect them. You should see this green point onto this part, otherwise it cannot be connected. In here, now they all connected with each other, as you see. We have no condition, we have so simple program, we have no loop or if condition. That's the simple solution for this flow charting operation. Try to solve other examples on your own. That's all for this part. See you in fourth week.